silent. Hold on.
Hey everybody, my name is Jakara Lewis and I am the author of the Kiss It series, TEAS Math Edition. KISS is an acronym for Keep It Super Simple, and what I wanted to do is I wanted to take the topics that you guys are going to see on your TEAS Math section and condense them down in between 1 and 3 steps in order to make it easier for you guys to be able to retain the information. So today we are at cluster number 3. So if you aren't aware, I broke the book down into 5 clusters. I grouped the topics together based on how similar they are in terms of solving, so that it was easier for you guys to be able to retain. So so far we've covered cluster 1, which included applying estimation strategies and rounding rules to real world problems, converting among non-negative fractions, decimals, and percents, comparing and ordering rational numbers, as well as conversions within and between standard and metric systems. We covered cluster 2, which covered, what did it include? Solving real world problems involving ratios, real world problems involving proportions, as well as real world problems involving percentages. And of course, those are all word problems, which I know you guys have a tough time with. So if you missed any of those videos, go ahead and make sure you guys go back and check them out. Leave me any type of feedback. Of course, that's always welcome. A diagnostic test has been added to the file, so what it does is it helps to gauge where you are right now in terms of the topics, and it helps to guide your studying, because I don't want you guys studying in the blind. So today's video is going to be super short and super sweet because we've moved into cluster 3. Cluster 3 isn't as much computation as the other clusters were. This is going to be more of a thinking, more of a thought process. So the very first section that we're going to look at today is explaining the relationship between 2 variables. There are going to be 4 things they're going to expect you guys to know how to do given this particular topic. You guys are going to have to know how to identify an independent variable. You guys are going to have to know how to identify a dependent variable. You guys are going to know how to have to know how to identify correlation given a graph, and you're also going to want to know oh Lord, you're also going to need to know how to identify correlation given a scenario. So I know oftentimes I don't see too many questions about this because people tend to overlook it because they think it's such a small thing. But what tends to happen a lot on the test is that people will miss these questions, and these questions are really easy if you take the time to prep. I always say again, certain questions are given. And when I say a given, it doesn't take that much time for you to prep in terms of retention, so you should make sure that you count those towards points that are easy for you to be able to score. You don't want to put yourself in a boat to where this is a question that you're missing when the prep for is not difficult at all. All right, so when we look at different definitions, we talk about independent variables. An independent variable is going to be a cause. That's going to be the variable that can stand on its own. That's the variable that can change on its own. That's the variable that can be changed by the experimenter. That's what's actually being tested. That's the independent variable. My sister is a bio major. Well, she already graduated, and she's a science teacher, so this is really her thing. So she'll be in the background chiming in every few minutes, I'm sure. So the independent variable is what causes the changes in another variable, which is our dependent variable. So the dependent variable is what's being measured. That's what's actually changing. And what tends to happen for this test is you could get a question, and they'll give you a scenario, which we'll go through a few, and they'll ask you to identify the independent variable, or they may ask you to identify the dependent variable. So as someone who's taking a test, you need to be able to understand, well, what's changing, what's being measured versus what's not, or what's influencing something else for you to be able to decipher between independent and dependent variable. So a tip to remember is the independent variable is what you can change, and the dependent variable is what changes because of that. All right? So if we look at an example, I'll write it out for you, and then we'll go through and we'll dissect it so we can see if you guys understand. So it says a teacher examines the time spent studying. No, it says the teacher examines the impact of time spent studying on test scores. So just in listening to that, what are you guys thinking? It says a teacher examines the impact of time spent studying on test scores. So first things first is you need to identify what are we talking about. What 2 things are we talking about in this scenario? So we
What
said,
are you testing? What are you measuring?
So what's being tested and what are you measuring? So it says the teacher examines the impact of time spent studying on test scores. So there are going to be a couple key words given these scenarios. Impact. impact of is a big thing. Because that's saying that whatever comes after that, that's what's causing the change in something. So in this scenario, it says a teacher examines the impact of what? Time spent studying. So that means that time spent studying, and another key too as well, I'll tell you in a second, has to be our independent variable because that's causing a change in something. A very quick shortcut that you guys need to know is that time is always independent. Time cannot be controlled by people. Time... Huh?
And age.
And age. It's in the book. I got it. It's right here. So time and age are two things that we have no control over. They're still gonna keep going and going and going and going and going.
You want me to open?
Yeah, you can. Time and age, they're gonna keep going and going and going. That's something that's completely out of our control. So in this point, impact means time is what's impacting something. That's what's going to change something. So, of course, in this scenario, that's going to be our independent variable. So, time spent studying is our independent. All right, and then, of course, what is that going to impact? That's going to impact our test scores. So, that's our dependent variable. So, if you think about it, just think about the given scenario. If I study more, then technically my test scores should go up. If I study less, then technically my test scores will go down. But of course, this is all up to the individual. It's not going to be the same for everybody. But this is what they're going to expect you to be able to do. If they give you a scenario, you have to be able to decipher what's the independent variable, what's the dependent variable. And that's it. And sometimes people will bypass, as I've always seen, this particular topic and they end up missing it on the actual test. And that's the extra point that they could have gotten. That's that one question that kept you from getting to nursing school. That was that one question that kept you from getting the math score that you needed. And you don't want that to be the scenario. And that's what tends to happen all the time. All right, Stephanie, give me another scenario.
Okay. Wait.
She is so slow.
Let's do.
Man.
Hold on, I could look one up real quick. I'm praying for it. I can say,
You know how they have that Jeopardy sound?
I know.
That's you right now. Let me see. We're trying to think of another scenario to give you guys because it is very straightforward, but you just have to make sure you understand the difference between the two. I'll upload some extra files just to give you guys some practice, and we'll go from there. It's not something. This isn't a topic that's like super big that you really have to stress about, but that's a large. This isn't a topic that you would have to actually stress about, but I do recommend that you practice enough so that you'll see y'all later. That you know so that you can get this given point. So let's see. Another question says, let me see. A school district examines oh no, I got a better one.
Oh, y'all got scared?
All right, it says a football player thinks he performs better when it's raining. What y'all thinking? What you think, Stephanie?
You say it again, I can't hear you.
A football player thinks he performs better.
No think.
He thinks he performs better when it's raining.
Okay. That's a good one.
So just think of that scenario. The reason why I like that one is because we eliminate that word impact. Sometimes people will get so dependent on the word impact that they don't realize that they're leaning on it. And you just have to have a firm understanding of what's being controlled, what's changing because of that. So if we think of this scenario, it says a football player thinks he performs better when it's raining. So one thing that always helps me with independent and dependent, one thing that always helps me with independent and dependent variables is I always like to look for my dependent variable first because I say what's being measured. So in this scenario, it says a football player thinks he performs better when it's raining. So what's being measured? His performance. So that will be our dependent variable, right? So he thinks he performs better when it's raining. Now, what is, oh Lord. So he thinks he performs better when it's raining. So I'm saying, okay, what's being measured? His performance. What is that impacted by? So what does he think is impacting his performance? It's the rain. That's the independent variable.
I have one for you.
You have one?
Yes.
Wait, I'm not ready yet.
Oh.
Not ready yet. All right, so just to reiterate one more time, when I'm approaching scenarios that deal with independent and dependent variables, I always like to ask myself first, well, what's being measured? I like to kind of work backwards. Everybody has their own way of doing it. I just always ask myself, well, what's being measured? What could actually change? Well, I know in this scenario, he says he thinks he performs better, which means that his performance has to be affected by something. And in this scenario, he thinks that it's affected by what? The rain. So in this instance, better performance or performing better would be our dependent variable, and the rain would be our independent variable.
All right, you ready for this one?
All right, give me another one.
Lemon trees receiving the most water produce the most lemons.
Now that's a lie. Why do you want me to write all that? It says what?
Lemon trees.
Lemon trees.
Yes, receiving the most water produce the most lemon. Just put cut it down.
Lemon trees receiving
The most H2O
the most water
produce the most lemons.
produce. I know this one. The most lemons. All right, so this science teacher always has to bring stuff that's just not related to math, but hey, we'll just rock with it. All right, so it says lemon trees receiving the most water produce the most lemons. So my go-to question is always, well, what's being measured? What could actually change in this scenario? So it says lemon trees, I can't see.
Yeah, lemon trees receiving the most water produce the most lemons.
There we go. Lemon trees receiving the most water produce the most lemons. So I know what could change. Obviously, the number of lemons that are being produced. And what is that dependent on? That's going to be dependent on how much water they get. Right? So let's look at this given scenario. So lemon production is going to be dependent on how much water they get. And of course,
sometimes it's always looking like it's not something I should say. I always look at it as a cause and an effect.
Right.
Something that you know that has to happen in order to have an effect. So I know if cause and effect happen differently with independent and dependent variable, but in some scenarios, something has to happen in order to have an effect. And it's something like independent and dependent.
So if you guys do think like cause and effect, so remember, like we said, common independent variables are going to be time and age. Common examples of dependent variable are height and weight. Those change because of other factors. And that's what you have to look at with questions like this. What is changing because of other factors? So make sure you guys are getting enough practice with independent and dependent variables, because there's a possibility that you may see it on there. And I definitely don't want you to miss the question because you didn't practice enough. All right, so the second half of determining a relationship between two variables is understanding how to identify correlations between variables, okay? And there are 3 different types of correlations they're going to expect for you guys to know. You have to know positive, you have to know negative, and you have to know scenarios where there's no correlation, okay? So I'm going to show you guys graphical representations. Of course, they're going to be sketches. They're not going to be official graphs. And we'll go from there.
Weight would be like a positive correlation, depending.
Normally, because normally the taller that you are, the more that you weigh. Yeah. Normally, right? And the shorter that you are, the less that you weigh. But with how obesity is, how we eat so terribly. All right, so these are going to be our graphical representation. So positive correlation exists when it's a relationship between two variables in which values move in the same direction together. Now, this is going to be key because people have a really tough time with positive correlation because they can't get past the idea that It occurs whenever variables move in the same direction, so they can both move up or they can both move down. Now, graphically, correlation is going to be represented by a scatter plot, and that's going to be a graph that has tons of those little dots, and positive is always going to rise from left to right. Okay, so as you can see, like it's kind of going up. This is going to be an example of positive correlation. Another thing that people have to remember in terms of positive correlation is that if I have two variables, right? If one variable is going up and the other variable is going up, that's positive correlation. If one variable is really,
It wasn't showing.
if one variable is going, it's okay. If one variable is going down, you can see this, right?
Yeah, hold on. No, yeah, you're good.
If one variable is going down and the other one is going down, then that's positive correlation. And when we talk about negative correlation, that's going to be a relationship between two variables in which variables move in opposite directions. So as one variable goes up, the other one has to go down, okay? And that's always going to be negative correlation. So negative correlation is that variables are going to move in opposite directions. Positive correlation, variables are going to move in the same direction, be it up or down. Zero correlation, this means that there's no relationship that exists between two variables, and it would be representative of this graph, but the dots are scattered all over, and there's no particular pattern of whether it's moving up or down. It's just kind of the same from left to right. So these graphs you have to know. If they give you a graph and they ask you what type of correlation does it represent, you have to know the difference between positive, negative, and zero, okay? And I believe I have some charts in my files. I will upload them for you guys so that you guys can have them on hand. Now, along with being able to look at the graph and identify the type of correlation, you also have to identify correlation given a particular scenario. So for our first scenario, it says, as the temperature increased in Florida, ice cream sales skyrocketed as well. I was putting ice cream instead of ice cream. Ice cream sales skyrocketed. So when they give you a scenario, first things first is you need to be able to identify, well, what two variables are they talking about? Because in order for you to assess the direction of the variables, you have to know, well, what are the variables? So in this scenario, it says, as the temperature increased in Florida, ice cream sales skyrocketed. So what two things are we talking about? Well, the first thing we're talking about is we're talking about temperature, obviously, because it changed. That's what you were looking at. And what did it do? It increased. And then we're also talking about sales, ice cream sales, and they skyrocketed. So sometimes they may not give you a word that definitely says increase or decrease, but you have to know vocabulary-wise what certain words may mean. So we know something skyrockets, obviously, is going upward. So if I know that the temperature is going up, and I know that the sales are going up, if they're moving in the same direction, that means that this has to be an example of positive correlation, okay? That one was more straightforward. It wasn't that hard for you guys to be able to decipher. And even if this was an example, say if as the temperatures in Florida decreased and ice cream sales plummeted or they plunged, you see how the temperatures are going down and the ice cream sales are going down? That's still an example of positive correlation because they're moving in the same direction. Don't get so caught up in the idea that, well, if it's going down, it can't be positive. That's always negative, because we're talking about correlation and we're talking about the relationship. We're not isolating one particular variable in its direction. We're looking at the direction of both of the variables together.
The one with driving miles, you know, the more you drive, the more, like the gas, you drive further.
Oh, I have that example in here. It says this distance travel in the amount of gasoline in your tank. So what type of correlation is that?
Negative.
Why?
Because you're driving more and you have to pay more for gas. Or am I doing it backwards?
It is negative correlation. So basically, the farther you drive, the less gas you have in your tank.
Yeah. Okay, so that's what I'm supposed to say. The further you drive, the less gas I have in my tank. Not the other way around.
But when I was tutoring somebody said, okay, but it could be positive because the further I drive, the more gas I need. So I was like, yeah, that is true though. But technically, that's why I had to change it to the amount of gas in your tank. Because the further you go, the less gas you have. Right? Because you have to continuously add it. All right, so if we look at our second example, it says Facebook's stock increase
Oh, I like this class.
last quarter after they experienced, why did I put a comma there? They experienced a drop in the number of fraudulent accounts. Yeah, I know I can't multitask. It's so hard for me to do that. So I'm gonna read it again.
So that is a negative correlation because they're going the opposite direction, right?
Mm-hmm.
They receive more viewers. Their viewers. I gotta wait till I see the question again.
All right, it says Facebook stock increased last quarter after they experienced a drop in the number of fraudulent accounts. So what two things are we talking about? What's being measured?
Stock increase.
All right, so our stock is one thing that we're talking about. All right, what's the other thing that we're talking about?
Drop the numbers.
But what dropped?
The drop in numbers of fraudulent accounts.
Right, so the number of accounts. Those two things we're talking about. I was talking about stock and we're talking about the number of accounts. All right, so we know that our stock increased, so that went upward. And what happened to the number of accounts?
They dropped.
They dropped. So because the variables are moving in opposite directions, that makes it
A negative correlation.
a negative correlation. And that's basically the scenario that they're going to put you guys in. You guys have to understand that when variables are moving in opposite directions, that it's going to be a negative correlation. All right. So again, in this scenario, it says Facebook stock increased last quarter after they experienced a drop in the number of fraudulent accounts. So two things we were talking about were Facebook stock as well as the number of fraudulent accounts. So the stock went up and number of accounts went down, and because they went in opposite directions, that marked that as negative correlation. All right, and that's going to be it today for explaining the relationship between two variables. There are 4 specific things they're going to be looking for you guys to know how to do in terms of this particular skill set. You guys have to know how to identify an independent variable. You guys have to know how to identify a dependent variable. You guys also have to know how to identify the correlation of 2 variables given a graph. And you also have to know how to identify the correlation of 2 variables given a particular scenario. So if you have not had time to practice on this topic, I have more than enough practice that I've provided in the book. The book features over 1,400 practice questions, 2 full-length practice tests, a diagnostic, and it gives you checkpoints as you go so that you can make sure that you're mastering the content before you move on. One of the biggest problems that people tend to have when studying in general, specifically with math, is that they study all over the place. All the topics have been organized in a manner to where all the skills build on themselves, so that you're not in a boat to where you don't have the proper sub skills to be able to execute certain questions. All right, and of course, if anybody's interested in purchasing the book, you can inbox me, and I can get that to you. Our next video will be focusing on evaluating information in tables, charts, and graphs using statistics. So I know a couple of you guys had a few questions about statistics, and that's what our next video is going to touch on. Of course, if you catch this video after I filmed it, your feedback, of course, is much needed. And if you guys have any questions about anything that we discussed today, feel free to drop me a line, and I'll make sure I respond. So thank you guys so much for participating today, and I'll see you guys a little bit later. Thank you.